Hi, I have a video here that's going to show us how to multiply and divide rational expressions. I had a previous video that showed how to simplify rational expressions. We will incorporate that in this video as well. So in this one, I'm going to multiply two fractions together. It's not any different than multiplying fractions that just have numbers in them. Other than obviously there's variables here that we need to deal with, but the concept is going to remain the same. When we multiply fractions, multiply your numerators together, multiply your denominators together. Now, I like to simplify before I do that, but you can multiply first and then simplify, or like I'm going to do, I'm going to simplify first and then multiply. So when I look up here, I start with simplifying. I notice that I have a 7 in the numerator and a 49 in the denominator. Both have a common factor of 7, so I'm going to divide that out of each of them, and that's going to become a set 1, and this is going to become 7. I go on to look at, well, I see 12 and 14. 12 has a factor of 2, so does 14, so the 12 is going to become 6, the 14 is going to become 7. I continue on. Now I notice, oh, I have a factor of 7 in the numerator and the denominator. This 7 is going to become 1. This 7 is going to become 1. Then I'm going to go to my variables. I see x squared in the numerator, x to the first in the denominator. This x is just going to become 1, and this x squared becomes x to the, and that will be a to the first. Then I'm going to go to my y's. I see y in the numerator, y in the denominator. This y is just going to become 1, and this y to the fourth will become y to the third. And then last but not least, I have the z's. This z is just going to become 1, and this z to the third will become z to the second. So I have done all of the simplifying. Now I just have to go back and multiply. Try to find out everything that's left. So in my numerator, I notice I have an x, and that's it. So equals x over, and then in my denominator, I have the 6, I have z to the second, and I have y to the third. So I like to put this in alphabetical order, so I'm going to go with the y to the third, and then z to the second. So I've taken that original rational expression, and I've simplified it to this rational expression. In my next one, same concept, but like I said before, I like to simplify first, but in order for us to simplify, we have to be able to see the common factors. Now the f's, yes, I can see those common factors, but this f plus 4, I don't know if this part right here has an f plus 4 in it right now. So what I'm going to do is I'm going to rewrite this as the f over f plus 4, because there's nothing for me to simplify in that first fraction. But this second one, I can factor that numerator into the two binomials. So now I look at, well, this is going to have to be a minus 8, and this will have to be a plus 4. So my factors of f squared minus 4f minus 32 are there, and then this f to the third, nothing to do there. Now, I can see those factors. I'll start with my f's. This f is just going to become a 1. This f to the third becomes f to the second. Now I look and I see, well, f plus 4 in the numerator and denominator, those are going to divide out. And all that remains now is f minus 8 in the numerator over f to the second in the denominator. I have simplified my rational expression. That's the multiplication side. Now, division side. If you remember how to divide fractions, this is going to be very similar. So the first thing I do when dividing fractions is take that second fraction and we flip it. We take the reciprocal. So remember, when you divide fractions, multiply by the reciprocal. So I'm just going to rewrite this. This part does not change, so we still have 5c to, oops, I almost wrote to the fourth. 5c to the second, d to the fourth, over 18q to the third r. Now remember, we're going to multiply by the reciprocal. So the 6 q to the fifth r to the fourth is going to be in the numerator, and now the 60 c to the second d to the second is going to go to the denominator. And now it's just like what we did on the previous slide. We're multiplying. So I'm going to go through and find those common factors. 5 and 60 have a factor of 1, so the 5 is going to become 1. The 60 is going to become 12. We'll go to the, I see the 6 and this 12, this both have a factor of 6, so the 6 is going to become 1, and the 12 is going to become 2. Then I'll go on to the, let's go to the C's. So I see c to the second, both in the numerator and denominator. Those both divide out, become 1. Go to my D's. I have a d to the fourth and d to the second. So this d to the fourth is going to become d to the second, and this d to the second divides out to become 1. Let's go to the Q's. Q to the third in the denominator, that's just going to become 1, and this q to the fifth is going to become q to the second. We subtracted the 5 minus 3. And then the r's, r to the fourth, r to the first, that r is going to become 1. This is going to become to the third power. And I think I have everything simplified. So now it's just a matter of multiplying everything in my numerator. So I've looked through, and it gets kind of messy trying to find everything that's still there. So I have a d to the second still remaining, and q to the second, r to the third. So when I write that, it's going to be d to the second, q to the second, r to the third. Over, now I go to my denominator. I have the 18, so I'm going to start with that. And then the q's are gone, the r's are gone. Oh, I forgot this 2. So let's take that back. This is not 18. 18 times 2 is going to put us at 36. And we said the q's, the r's are gone, the c's are gone, and the d. Okay. I guess that's it. Let me slide this over just so it looks a little prettier. And I have simplified my rational expression. And then last but not least, we have another division problem where, again, I'm going to need to factor first so that I can find all of those common factors that may divide out. So I'm going to do two things at once here. I'm going to rewrite it by factoring it, and I'm also going to multiply by the reciprocal. So the b plus 3, nothing to factor, but here I have a 4 that's common to both terms, so then I'd have b minus 3. Now here's where I'm going to multiply by the reciprocal. So first, I'm going to take this and put it into the numerator. So the factors of that one will be b, and then we're going to have a minus 3 and a minus 1. And now this, what was in the numerator, is now going to go down to the denominator. And that's going to, we're going to have b, and b multiplies together to be negative 30, but adds up to be negative 7, so that would be negative 10 and positive 3. There we go, it's all factored. Now it's just a matter of going through and finding those common factors and dividing them out. So I see a b plus 3 here with a b plus 3 here. Those will divide out, become 1. The b minus 3 here and the b minus 3 here, those are going to divide out to be 1. All that remains then is b minus 1 in the numerator, and the 4 and the b minus 10 in the denominator. So sometimes you could leave it written like that, or sometimes we multiply those factors back together to get 4b minus 40. Either one of these would be an acceptable answer to the original division problem there. And that's, actually, I have one more here. Good old Usain Bolt set the 100-meter dash world record in 2000 with a time of 9.58 seconds. We want to know what his average speed is in miles per hour. It's always kind of fun to figure out how fast you're running. I like to compare it to driving a car. So when I look at this problem, I notice that I want it in miles per hour. So I see this as distance per time. Because the original problem doesn't tell me miles per hour, it tells me meters and seconds. So if I write it in distance per time, that's going to be 100 meters per 9.58 seconds. Now I just need to do some converting here. And this is where our unit multipliers come in handy. So the first thing I'm going to work on is I'm going to work on getting my distance from meters into miles. So what I'm going to do there is, first I'm going to convert those meters into centimeters. And I know there are 100 centimeters in 1 meter. The reason I do that is because my meters just divide it out. But then I got to get this converted into the English system. So I got to go from centimeters to inches. So I know there are 2.54 centimeters in 1 inch. So I'm going to multiply by that, because now my centimeters have just divided out. But now I got to convert my inches into miles. So the first thing that I would do then is I would go to feet, because I know there are 12 inches in 1 foot. Now, inches are not gone, but now I got to convert feet to miles, and I know there are 5,280 feet in 1 mile. So now when I look at it, if I just look at the labels, I am in terms of miles per second. But I don't want it in miles per second, I want it in miles per hour. So now I got to work on converting the seconds into hours. I ran out of room, so I'm just going to have to come down to another line. So I'm going to start with, there are 60 seconds. Probably should have done SEC, I think. Would have been a better label for seconds. So there's 60 seconds in 1 minute, because what happens now is my seconds from the denominator there divide out with the seconds in the numerator here, and then that's minutes. Now I need to get to hours, and I know there are 60 minutes in 1 hour. Now my minutes will divide out, and my label is hours. The only thing now that remains is just multiplying and dividing all of this. So this is where I go and I grab my calculator, and I, on my calculator, will type 100 times 100 times 60 times 60, because that's all my numerator. And then I'm just going to start dividing. And then I'm going to continue on my calculator. I divide by 9.58, divide by 2.54, divide by 12, divide by the 5,280, and that's it. And when I punch that all on my calculator, I find out that Usain Bolt average speed in that 100-meter dash was 23.35 miles per hour. In a car, maybe not so fast. When you use your legs, extremely fast. And that's going to conclude my lesson on simplifying rational expressions when we multiply or divide them.